Have you been looking for a video on how to use the E6-B flight computer? Well, this video is it. So it doesn't matter if you're a student pilot learning E6-B for the first time or you're a private instrument commercial pilot needing a refresher, I'm going to help you learn it. So hey, I'm Dr. Andy Moltar. I'm a flight instructor, a CFI IIMEI. I used to be a corporate pilot, and now I'm a professor of aviation. And the E6-B is one of the things that I teach my students all the time on how to use it properly. So yeah, when you first look at a E6-B, especially if you've never looked at it, if you've never used one before, it looks intimidating, but you'll soon come to realize that this is a very quick and easy tool to use with just a little bit of practice. After you get to use it a little bit, you're gonna think, man, whoever invented this is a genius. Well, it's actually a pretty simple device, and it real quick, we call it the whiz wheel. You just find the answer super quick. And so to help you with learning this, I actually have a worksheet that you can download for free. And so this is it, the E6-B Flight Computer Worksheet, and I've got 180 practice problems that you can work through on your own. And I'm going to go through some examples with you in this video. And so the way that you can get a copy of this worksheet is you go to my website, moltaraviation.com, and I'm going to go ahead and leave a link to this website in the video description below. So when you get to my website, you just have to scroll down a little bit, and I've got this right here where you just enter in your email address, and I'll email the E6-B worksheet right to you. And don't worry, I'm not going to sell your email address. That's not what I'm about. I'm just here to help you all learn how to use the E6-B. And so yeah, you enter your email address in right here, or if you go to the Pilot Resources tab, I've got a lot of different resources available for you on the top left at the time of this video. Right here, you just enter in your email address, and then if you want, you can check out what else I have available to you. A lot of free resources for you. And then one other thing is, when it comes to getting an E6-B, I do recommend you get one of these metal E6-Bs. And so, Gleam has, I don't know, it's a type of like paper stock, a very thick paper stock E6-B that, I mean, it's okay, but I really recommend the metal one. And so if you go to my Pilot Gear website, portion of my website, you can click on Flight Computers, and it takes you here. And so ASA makes a really good one, made out of metal. It's going to let, the one I have, it's actually made by Jepson, but it doesn't matter. But the one, these metal ones, they'll last. I mean, I've had mine for 20 years, and so I'm old, but but it lasts. The one that you can get from Gleam, it's okay, but I don't know if it'd still be usable for me after 20 years. And so I do recommend this ASA E6-B flight computer. I've got my affiliate links here, so if you want to use my affiliate link, I'd appreciate it, but you don't have to. And then right next to it, I also got the CX3 flight computer. Now those CX3 flight computers, they're pretty expensive, and I really don't recommend them. But the reason why I have it up is because I know some people they do not want to use the E6-B flight computer, and so if you are going to get one of these fancy flight computers that costs a lot of money, then yeah, the CX3 is the one I recommend. But anyways, let's just go ahead and start working on some problems. So on this worksheet, I have a whole bunch of different problems. So we have some to convert between Fahrenheit and Celsius and Celsius to Fahrenheit. And then the next set of problems is going to be for distance conversion. So going from nautical miles to statute miles, from statute miles to nautical miles. Then the third set of questions I have for you are to figure out your speed, distance, and time computations. And then the next set of questions is going to be for fuel burn computations. And then finally, or actually no, before finally, and then we have our true airspeed density altitude computations. And then finally, we have our wing correction angle, true heading, ground speed calculation problems. And so throughout this video, I'm going to have, oh, and by the way, I do have an answer sheet for you for each of those sets of problems. And if you want to hop around, you can. I'm going to put timestamps in the video description below. So if there's only a certain set of questions you want to work on, then you can just go ahead and skip to that chapter. So if you don't already have an E6-B flight computer, you can use the University of North Dakota's E6-B simulator. And so, this would be a good fix for you while you're ordering and waiting for it to be delivered for your E6-B. And so what I did here was I just went to Google, put in UND, University of North Dakota E6-B simulator, and then just click on their link, and here we go. We have the flight computer side, and then we also have the wind side. And so we'll be going through how to use this on both sides. Okay, so the first set of questions we're going to go through are the temperature conversions. And so for the temperature conversions, I'm only going to go through a few of these questions, so in each set. And so that way you can work on the rest of them on your own. But so here, we'll go and work on the first one, 32 degrees Fahrenheit to Celsius. Now, I just already happen to know that that's 0 degrees Celsius. Um, but we'll go ahead and look to see how to do it on the flight computer. And so we just go to the very bottom of the flight computer, and you'll see here's our temperature conversion scale. We have 20 degrees Celsius right here, 40 degrees Celsius right here. These are 2 degree Celsius, or I'm sorry, these are Fahrenheit. So 20 degrees Fahrenheit, 40 degrees Fahrenheit on the bottom, and then on the top we have the Celsius. And so we got, these are 2-degree increments, so 20 degrees, 30 degrees over here, and then 32 degrees matches up with 0 degrees Celsius. So 32 degrees Fahrenheit on the bottom, 0 degrees Celsius on the top. So I feel pretty confident about that answer. Let's go and do the next one, 50 degrees Fahrenheit to Celsius. So 40 degrees, 60 degrees. So in the middle, 50 degrees would be 10 degrees Celsius. So I'll go ahead and enter that in. And then let's just do a couple of the Celsius to Fahrenheit ones. All right, so we got let's just go ahead and do 15 degrees Celsius. So 15 degrees Celsius, I'm going to go up to the top scale here. Got 0, 5, 10, 15 right here. I go down, and we're looking at like 59 degrees Fahrenheit. So I'm going to put in 59 degrees Fahrenheit, and then let's do the next one, 20 or let's go -5 degrees Celsius. Yeah, let's do that, -5 degrees. So -5 degrees, we've got 0, -5, and we're looking at about 23 degrees Fahrenheit. So I'll say 23 degrees Fahrenheit. And so now that I've got a couple of them done, let's see, we did 1, 2, 18, and 20. And so 1 and 2 were 0 and 10. 0 and 10 right here. So very good for me, and hopefully you too. Whoops. And then we did 18 and 20, and for those, the answers we got were 59 and 23. So 59 degrees, and then 20. Let's see what is going on here. 18 and 22. That's why. 23 degrees. Very good. So yeah, I'm dyslexic. I will make all the mistakes in the world. And don't fret if you get something off by like a degree or two, or a degree from me, or when we're going through any of these problems, if you're off by like a nautical mile, a degree, a few knots, that's okay. This is not an actual like computer, so it's not doing math calculations in the background. So um, just give yourself a little grace, and it'll be okay. So, all right, so now we're going to go ahead and work on the distance conversions. So, let's say you're working on a knowledge test and they give you a distance in statute miles, or they give you a distance in nautical miles, and they wanted you to convert to statute miles, which probably isn't going to happen, but if you needed to, you could. So we'll just go ahead and convert 10 nautical miles to statute miles. So I'm going to go up to the E6-B here. And by the way, if you have an E6-B that doesn't look exactly like this, it has all the same functionality. It just may look a little different, but it's all there. So you should see like this little arrow right here where it says not with the arrow pointing down, and then this statute miles right here, arrow pointing down. And so if we're going to do 10 nautical miles to statute miles, what I want to do is I want to put this 10 right below the nautical mile arrow, and then I'll follow that arrow to where it says stat for statute miles, and I'll come down, and it looks like 10 nautical miles is in between 11 and 12 nautical miles. So we're looking at like 11.5 nautical miles, or I'm sorry, 11.5 statute miles. Um, Now, whenever I'm doing things like this, I like to just go ahead and round up to the next whole number for these mile conversions. So we'll say that 10 nautical miles is 12 statute miles. Now, I know if you're the engineer type, you're like, no, that is not 12 statute miles. That is 11.53 statute miles. Well, you're correct, but when it comes to learning to fly, sometimes close enough is good enough. And if I tell myself that I need, I'm going to fly for 12 miles, then what I'm saying is, it's going to take me a certain amount of time. It's going to take longer to fly 12 miles than it is 11 miles or 11.5 miles. And so when I say, okay, it's going to take me an extra minute, that means I'm going to need an extra minute of fuel. Well, if I carry an extra minute's worth of fuel, is that okay? Yes. If I end up with not enough fuel, is that okay? No. So as long as you round toward being conservative with your numbers, then it's fine. And you'll see later when you're doing your cross country planning, this information that we're using is all based on forecasted weather. And so even if you're, the forecasted weather, it really is just the best educated guess that the meteorologist could come with. And so if you're a little off, as long as you're more conservative, you'll be okay. So I'm going to go ahead and put 12 for my statute miles. Let's do another one. We'll do 15 nautical miles to statute miles. So I'm just going to put 15 over here below the arrow for nautical miles. And below the statute mile arrow, I'm going to read above 17. And even though it's closer to 17 than it is 18, where it lines up, I'm just going to go ahead and say 18. All right, let's go and skip down a little bit. So we'll go ahead and say, let's go to the last two problems here. 220 statute miles to nautical miles. Okay, so we're going to say 220 statute miles to nautical miles. Now, the thing with these numbers is that any number that you see here on the outer scale or this middle scale with like the 22, the 23, 24, or whatever, those can be any numbers that you want to the power of 10. And so this 22, if I multiply it times 10, it becomes 220. And so, let's just say it's 220 nautical miles. And then when I follow this statute mile arrow down to my nautical arrow, I get a little over 190. And so we'll say that, this is 190, this is 200, and these little tick marks here are increments of 2. So we could say that this is that 220 statute miles is 191 nautical miles. So we'll say that was 191 nautical miles for 220 statute miles. The next problem we had here was 180 statute miles. So remember, these are powers of 10, so we'll say this 18 is 180. And so if we follow that arrow, the nautical miles would be 150, 152, 154, 156. And since it's a little past 156, I'm just going to go ahead and round up to say 157 nautical miles. Okay, so the first two answers we got were 12 and 18. Let's go ahead and check those. So I got 12 statute miles, 18 statute miles. Very good. And let's go back up. And so the next ones I got, the last two were 157 and 191. So 156 and 191. So I was one off from the answer that I gave. But you know what? That's okay. All right, so now that we got those easier ones out of the way, let's go ahead and work on some speed, distance, and time. All right, so for my first problem, let's say we're flying at 100 knots ground speed. The distance we're flying is 50 nautical miles, and we want to know how many minutes is that going to take us. So 100 knots ground speed, 50 nautical miles, how many minutes? Let's see here. So when I scroll out a little bit, I want you to see the face of this card here. You know, the nice thing about the E6-B is it tells you how to use it. And so if we're doing speed, distance, and time, look right here where my cursor is, and you'll see, put the black arrow on our speed. So whether you're doing miles per hour or knots, it doesn't matter. Um, it's just, so we're using knots. And then, what is a formula for speed? It's distance over time. See? And it equals distance over time. And so the way we're going to use this is we'll put our black pointer, that black triangle, on our speed, and then we'll read on the outside what our distance is, and then on the inside, however many minutes that's flying. Now, this most inner scale, that's going to be in terms of hours, but we really don't use that for anything. I mean, you can if you want, but let's just think of 2 hours. 2 hours right here. You see my cursor is 120 minutes. We go up to the middle scale, and it's 12, which is a power of 10, could be 120. And so whenever you're using this E6-B, you always need to make sure that the answers you're getting make sense. So right now, if I have the black pointer set to 60, so that's our speed, 60 knots, ground speed, then we will cover 120 miles in 120 minutes, which is 2 hours. Now, does that make sense? I'm going 60 nautical miles per hour, and so that means I'm going a nautical mile per minute. And if I go 120 nautical miles, well, that's 120 minutes. So that makes sense to me. And so the problem we're going to do is 100 knots for 50 nautical miles. So I'm going to, following this this formula on the bottom, put my black pointer on my speed, read the distance on the outside and the time on the inside. So we said we're going 100 nautical miles, or 100 knots for our ground speed. So I'm going to put that black pointer on the 10, which remember, we're saying is a power of 10, so that's 100 knots. And then we want to read 50 on the outside for our distance. And on the inside, we'll get our time. So 50 miles on the outside, and right below it, we have our time. Look at my cursor, 30 minutes. And so remember, we just want to make sure, does that make sense? If I'm going 100 nautical miles per hour and I'm traveling 50 nautical miles, well, that makes sense that in half an hour of going 100 nautical miles per hour, half an hour, I'm only going to go 50 miles. So that makes sense. So I'll just go ahead and put 30 minutes for my answer. So we can go ahead and do another one. 120 knots at 40 nautical miles. 120 knots with a distance of 40 nautical miles. So 120 knots. I'll go look for 40. There we go. So 40 on the inside, 20 minutes. And that makes sense. Okay, let's go ahead and skip down. So now we're given our ground speed and our time, and we have to figure out what distance we're flying. So if we're flying at a speed of 90 knots and our time is 40 minutes, so I got to put my black pointer on 90. And our time is 40 minutes. So you look at my cursor, I'm looking at the inside scale, 40. On the outside is my distance, 60. 60 nautical miles. All right. Let's go and do one more. So if I'm going at a speed of 115 knots for 25 minutes, so my speed is 115 knots right there. And, make sure you don't trip yourself up. Remember, these are all powers of 10. And so 115 knots, you got 100 knots here, 110 knots here, 120. If you had accidentally put your black triangle over here, or the 15, because you're thinking 115, oh yeah, the 15. No, that's 150. So 115 in between 110 and 120, that'd be that right there. And we said we're flying for how long? 25 minutes. So I'm going to look on the inside for 25. 25, it looks like 45, 46, 47, 48 miles. So I'm going to go ahead and put 48 miles. All right, let's just do 2 more of these. So now I'm given the distance that we're flying and the time that we're flying, but we don't know our ground speed. So how fast do I have to go to be able to fly 60 nautical miles in 30 minutes? So all we're going to do here is just match up the outside with the inside. So 60, miles for my distance on the outside, and on the inside will be 30 minutes. And so we know that the pointer then will tell me my speed, and it looks like my speed is 120 knots. Okay, so I'll go ahead and let you practice the rest of the problems on this worksheet, but let's go and see how we did. So for problems 1 and 2, I got 30 and 20. So 30 minutes, 20 minutes, very good. So for questions 11 and 12, I got 60 and 48 nautical miles. 60, 48 nautical miles, very good. And then for the next set of problems, for number 21, I said that we had 120 knots for our ground speed. 120 knots, hot dog. So hopefully you're feeling a lot more comfortable with this. I know when you first start using the E6-B, it can be a little intimidating, but it's fairly straightforward and easy to use, and with just a little bit of practice, you'll become a master in no time. So now we're going to go ahead and work on some fuel burn computations. So the first problem we'll do is we have a fuel burn rate of 10.5 gallons per hour. We're going to be flying for 6 minutes, and we want to know how much fuel are we going to burn. So I'm going to go back to my E6-B here, and I'm going to go ahead and move this card. And like we did for the speed, it also tells you how to figure out, if you ever forget, how to get your fuel burn. So we're going to put our black pointer on the fuel burn rate, gallons per hour. And so that equals total gallons on the outside scale, and then the time on the inside scale. And so just to remind myself, what do we say? 10.5 gallons per hour in 6 minutes. Okay. So I'm going to put my black pointer on that 10.5. So there I go. On the outside, or my black pointer, I said 10.5 gallons per hour. And then now on the inside, I'm going to find 6 minutes and then read the outside scale. Okay, so I'm looking for 6 minutes. Remember, these are all powers of 10 on this inner scale here. So 5 minutes, 5.5 minutes. Oh, the black pointer, 60, is 6 minutes. And so then on the outside, I'm going to go ahead and read what our fuel burn is. And so here, remember, these are all powers of 10, and the answers have to make sense. And so if I'm burning 10.5 gallons per hour and I'm flying for 6 minutes, how much fuel am I going to use? Well, it wouldn't be right to say 10.5 gallons in 6 minutes at a rate of 10.5 gallons per hour. So this would actually be 1.0, 1.1. So we're looking at 1.05 gallons. And so the way I like to do this is I like to just round it up to the nearest tenth. So I would say 1.1 gallons. So this is 1 gallon, 1.1 gallons. So this will be 1.1. I'll just round it up and say this is 1.1 gallons. All right, so let's go ahead and look at this next one, 8.4 gallons. in 45 minutes. So I'll go ahead and put this black pointer on 8.4. Remind myself, what was the time? 45 minutes. So now I'm going to look for 45 minutes on the inside scale. And so 45 minutes, I'm in between 60 and 70, or 6 and 7. And so I'll count 6.1, 6.2, 6.3. So 45 minutes is 6.3 gallons. Now that makes sense because I'm burning 8.4 gallons per hour and I've got 45 minutes that I'm flying. So that's about 3/4 of an hour. 3/4 of an hour at 8.4 gallons per hour. 6.3 seems like a reasonable answer. All right. And then let's just go ahead and here, we'll go ahead and look at the answers. So for the first two, 1.1 gallons and 6.3 gallons. 1.1 gallons, 6.3 gallons. Very good. Okay, well, let's go ahead and work on the next set of problems there. And so here we're given our fuel burn and the gallons that we're burning, but not the minutes. So let's go ahead and find that. 10.2 gallons per hour, and we're burning 2.5 gallons. So 10.2 gallons per hour, and it was 2.5 gallons. So power of 10, we're looking for 25 here for 2.5 gallons. And so it looks like we're going to be flying for about 14 minutes, 14.7 minutes. So we'll just call that 15 minutes. Okay, let's work on this next one. 12.5 gallons per hour, and we're burning 36.5 gallons. Now, just looking at this, if I'm burning 12.5 gallons per hour, and I'm gonna totally burn, and my total burn will be 36.5. That's almost 3 times as much as this 12.5. And so I could expect that this is going to take me about 3 hours, or how many minutes would that be? 180 minutes. That's, somewhere around there is going to be my guess. But just to make sure we understand what's happening so it makes sense. And so 12.5 gallons per hour, and we're burning 36.5 gallons. So, I need to remind myself. 12.5 gallons per hour. And we're burning 36.5 gallons. So here I am, 35, 36, 36.5. And it looks like 170, 170, 171, or 172. You got to make sure you make note of these increments. These are 2-minute increments. So 172, 174, about 175 minutes, which is pretty close to that 180 minutes that we said. So I'll go ahead and say 175 minutes. Okay, so these are problems 11 and 12. And we said 15 and 175. 15 minutes, 176 minutes. Okay, you know what? I was one off, but you know what? That's okay. So close enough. All right, let's go ahead and do one more of these. So here we're trying to figure out what the fuel burn rate is in gallons per hour, and we're given 1.5 gallons and 6 minutes. So we burned 1.5 gallons in a time of 6 minutes. And so here is just matching up the outside with the inside. So 1.5 with 6 minutes. So let's see, 1.5. So that's going to be this 15 here. So it's power of 10, 1.5 with 6 minutes. And as you can see here, that black pointer just happens to be pointing to 15. So that means our fuel burn is going to be 15 gallons per hour. And since the black pointer was pointing there, I'll go ahead and do one more problem with you. So we're burning 5.2 gallons at 15 minutes. So 5.2 in 15 minutes. So I'm going to go over here, 5.5, 5.2, and we said 15 minutes. 5.2 gallons per hour. in 15 minutes. Let me just remind myself, make sure I said that right. 5.2 gallons in 15 minutes. So now I just have to see where, so 5.2, 15, I just have to see where the black pointer is pointed at. And it looks like I'm at 20.8 gallons per hour. 20.8. So let's go ahead and check the answers, make sure we're right there. So 21, 22, 15, and 20.8. 15 gallons per hour, 20.8. Looks like we're right again. All right, so hopefully you're feeling better about the E6-B now. Now we're going to hop into calculating the true airspeed and density altitude. Here we're given an example of 3,000 feet. So the pressure altitude is 3,000 feet, temperature is 25 degrees Celsius, and our calibrated airspeed is 100 knots. So before we even start to answer this question, I want to go ahead and just talk about something here. So let me ask you, do you remember what the definition is for density altitude is? All right, so the definition for density altitude is pressure altitude corrected for non-standard temperature. And so if density altitude is equal to pressure altitude corrected for non-standard temperature, then what do you think density altitude is going to equal when we have standard temperature? Well, it's going to be that density altitude equals pressure altitude. And so let's try to think of an example where this might apply. Now, if you remember, standard temperature is 15 degrees Celsius. And so let's say we're at an airport like Miami, that's pretty close to sea level. So we'll just say it's at sea level. And we'll just say it's a standard day where, the elevation equals the pressure altitude. And so it's, the pressure is 299 or 2 inches of mercury, and the temperature is standard temperature, 15 degrees Celsius. So if we have a pressure altitude of 0 and a standard temperature of 15 degrees Celsius, what do you think density altitude should equal? Well, density altitude is pressure altitude corrected for non-standard temperature. So if we do have standard temperature, then density altitude is going to equal 0 because the pressure altitude is equal to 0. And so that's how I like to put, that's the reference I like to have when I start thinking about these types of problems. And so if you see my cursor, we're going to look at these tables on the right. And so here you see this little window, pressure altitude, thousands of feet. And make sure you're looking at the right side, not the left side. So on the right side, we set our pressure altitude as 0, and I'm going to match that up with 15 degrees Celsius. Now, so here's 0 degrees, 5 degrees, 10 degrees, 15 degrees Celsius. And so we said we had a pressure altitude of 0, 15 degrees Celsius. And if you look at this next window on the top, right above it, it's pointing at saying that the density altitude is 0. So, hey, now we understand how that all works. I always like to do that, especially if I haven't touched a E6-B in a while. I always like to remind myself of this just to make sure I know I'm using the E6-B correctly. And then I want to show you another portion here. Notice how we have these 3 letters. If you see my cursor, CAS, I know you're reading it upside down. But so calibrated airspeed is on the inside, and then on the outside, so on the outside it says TAS right here if you see my cursor. So true airspeed's on the outside scale, calibrated airspeed's on the inside scale. So now that we know all that, we can go ahead and work through this first problem. So if we have a pressure altitude of 3,000 and a temperature of 25 degrees Celsius, so let's go ahead and enter that in. So 3,000 foot pressure altitude and 25 degrees for our temperature. So I know that I get to zoom in on here, but just do your best. Put on your reading glasses if you need it. But we got 3,000 feet and 25 degrees Celsius, and it'll tell us what our density altitude is. Now this is the worst part of using the E6-B is that I know you're looking at your E6-B right now, and that it's very hard to read. I'd call that 4,900. Close to 5,000 feet for my density altitude. And so I'll just go ahead and put 4,900 feet. If I'm wrong, that's okay. I'm doing my best. And then our calibrated airspeed, what we're given is 100 knots. And so, like we said, on the inside is calibrated airspeed, on the outside is true airspeed. And so 100 knots right here, the 10, I'm going to look up. And so 100 knots calibrated, here's 100, here's 110. So 105, 106, 107. So between 107 and 108 knots. I always like to be conservative when I'm rounding. And so when it comes to speed, if I say I'm going slower, it's going to take more time. And if it takes more time to fly, that means I'm going to have to burn more fuel and I want to carry more fuel. So I'll just go ahead and round down to 107 for my true airspeed. All right, so let's go ahead and do one. Let's go ahead and look at that answer. So let's see here. Okay, so 108 knots and a density altitude of 4,900 feet. So I got lucky on the density altitude and I was one off, and that's okay. You know, if you did it and you got like 4,500 for your density altitude or 5,500, you're in the ballpark. That's close enough. Okay, so let's go ahead and do the second problem. 5,000 foot pressure altitude, and it's 10 degrees Celsius outside. So 5,000, 10 degrees. So I'll go back up here, 5,000 and 10 degrees. Actually, instead of doing that problem, let's go ahead and do one of these negative ones. So I got 10,000 and negative 5 degrees Celsius. So number 5 here, question number 5, 10,000 foot pressure altitude, negative 5 degrees Celsius. So 10,000 with a negative 5. All right. So hopefully you can see it here. I've got 10,000 foot pressure altitude and 5 degrees or negative 5 degrees Celsius. So I've got a density altitude, well, pretty close to 10,000. So I'll just go ahead, I'll just go ahead and put in 10,000 for my density altitude. Put a comma in there to look pretty. And then we're given a calibrated airspeed of 140. So I'm looking for 140 on the inside. And on the outside, I've got 160, 162. Well, we'll just call it 163, but I'll go and round down and say 162. So we'll go and say 162 knots for our true airspeed. And so this is number 5. We said 162 and 10,000. 163 and 10,000. So I was pretty close. So good enough. All right, let's just do one more of these. Here, instead of giving us the calibrated airspeed, they give us the true airspeed for these lower sets of problems. So I'll just go ahead and, it's going to be the same thing what we've been doing, except for, we'll be looking at the true airspeed on the outside to find our calibrated airspeed on the inside. And so we got a pressure altitude of 4,000, a temperature of 20 degrees Celsius. So 4,000 foot. So 4,000 feet with 20 degrees Celsius temperature. That looks pretty good to me. And then my pointer here, oh man, that's going to be tough. Let's just call that 5,400 feet. I know it looks worse on your E6-B, but yeah, so that's 5,000, 6,000. So we'll just call that 5,400 feet for our density altitude. 5,400 feet for density altitude. And then we're given a true airspeed of 120 knots. So remember, true airspeed's on the outside. And so my calibrated airspeed, I'll go ahead and call that, if this is 110, this is 111. I'll just go ahead and call it 110 knots for my calibrated airspeed. And let's go see. So this is question number 16, 110, 5,400, 110, 5,600. Yeah, close enough. All right, so now we're going to go on to our last set of problems. So if you made it this far, you're doing a great job. And hopefully by now you're feeling really good about your skills with using the E6-B. It truly isn't that difficult. It just takes time and practice. So if you're still having a little problem with it, go back, watch the sections, and just keep practicing. Eventually, this will become second nature for you, and you'll turn that whiz wheel around so quick, those answers will just come to you real quick. All right, so now we're going to go ahead and go to the wind side of the E6-B to work on these problems. So let me go and show you that. So here we were on the flight computer side. Now, you just have to flip your E6-B over. I'm going to click this button, go to wind side. And so this is what the wind side looks like. Now, one thing I always want to do is you have this little center hole, the grommet. We're going to go ahead and put that right over the 0, over 100, which we're going to identify as our 0. And so we're just saying that 100 represents a 0 when we put that hole over it to begin with. Now, the nice thing is, at the very top, it should tell you what the directions are for how to use your E6-B. And so the first direction says to set the wind direction under the true index. Okay, so what's our wind direction? So our wind direction here is 030 at 20. Okay, so I'm going to come down here. So here's our true index. So step 1, set wind direction under the true index. So this little arrow here is our true index. So we're going to put 030. So wind direction underneath our true index, 030. And then our second instruction here is mark wind velocity up from the center point. So I'm going to go over here. And so we said the wind speed was 20 knots, 030 at 20 knots. So I'm just going to put my little mark right there. So 030 at 20. So I just counted up 20. So 100 represents 0. So 110 would represent 10. And then 120 would represent 20. So marking 20 up from the center. I did so right there. Whoops. That's not what I want to do. Let me put it back. All right, very good. Now we'll go to step 3. So step 3 says set the true course under the true index. So before we did the wind, now we're doing the true course. So our true course is 360. So set the true course under the true index. So go back over here. So our true course, we set 360. Put that underneath the true index. Okay, did that. So you see there's 340, 350, 360 underneath the true index. And now I can go to so we just did step 3, set true course underneath the true index. Now step 4, slide the wind velocity mark to the true airspeed. So let's go over here. Our true airspeed, our true airspeed is 120 knots. So slide the wind velocity mark to the true airspeed. Okay, I want y'all to be careful with this. So we're sliding the wind velocity mark to the true airspeed, not the center hole. So the wind velocity mark is that red dot that I drew. And for you, I want you make sure you're using a pencil when you're doing this. That way you can erase it later. Don't be using a pen or a marker. So anyway, so I got my wind velocity mark right here on the 120 knot line. So it said place wind velocity mark on our true airspeed. So there we go. And then we read the next instruction. Whoops, that's not what I want to do. So we just did step 4, slide wind velocity mark to true airspeed. Number 5, ground speed reads under the center. So ground speed reads under the center. So what we did here is we put our wind velocity mark. Whoops, dang, I'm just messing that up. Okay, so we placed our wind velocity mark on our true airspeed, and now we're going to read the ground speed underneath the center. So just be careful, make sure you're counting the increments right. But here it looks like the center is over 104 knots. So I'm going to go ahead and mark that down. So my ground speed is 104 knots. And then now I need my wind correction angle. So my wind correction angle, go back up here, number 6, wind correction angle reads between the center line and the wind velocity mark. So when I zoom back in here, so the wind correction angle reads between the center line and the mark we made. And so that's about 5 degrees, and that's 5 degrees to the right. So I'm going to put 5 degrees to the right. So I just counted 1, 2, 3, 4, 5. And then next, the last thing we need to figure out is our true heading. So true course, just as a reminder, true course is when we draw a line on our sectional chart, and we use the lines of latitude or the lines of longitude to figure out, and we use the plotter, we can figure out our true course. But when we adjust our true course by wind, we get our true heading. And so my E6-B here, let's see here. So right here, it tells us everything we need to know. True course, that's plus or minus variation. We don't want that. But over here in the center, it says minus left plus right. And so even though it's magnetic course, when you adjust true course for wind, it becomes true heading. When you adjust magnetic course for wind, it becomes magnetic heading. And remember, true course is in relation to the true North Pole. Imagine you have a globe. The connecting points for the mount go through the North and South Pole, but the magnetic North Pole is like somewhere in Canada, and it moves over time. So anyways, we'll take our true course and adjust it by our wind correction angle. So minus left plus right. So our true course of 360 plus that 5 right, well, I'd call that a true heading of 005. And just to give you a better understanding of what we're doing here, let me go back down here. So we said that our wind correction angle was 5 degrees to the right. Well, we have our true course underneath the true index right now. What's 5 degrees to the right? Well, it's a course of 005. So hopefully that helps you with that. But we've answered that. Let's just check to make sure our answers are correct. So 5 right, 005, and 104 for our ground speed. So 5 degrees to the right, true heading of 005, and a ground speed of 102. I said 104, but you know what? That's good enough. That's close. All right, let's go ahead and work on the next one. So here we have a true course of 180 degrees. You have a wind direction of 030 at 40, and a true airspeed of 140 knots. So I'm going to go back to my E6-B, and remember we're using a pencil, and you want to go back and erase your pencil mark. Because if you leave that pencil mark from our previous example, or when you're doing your cross-country flight planning, you're just going to confuse yourself. So we'll go ahead and erase that mark. I have to do a couple clicks here. Oh. All right, so let's go back. And so 030 at 40 is my wind direction. So I'm going to go up here. Oh yeah, and first I want to set that center hole to over 100. And put the wind direction underneath the true index. And if you need to, you can read the instructions on your E6-B. So 030 underneath the true index. And then I'll mark 40 up from the center. So there's my center hole down here. Go up 40. Right there. Okay. My true course was 180 degrees. So now I'm going to twist this until 180 is underneath the true index. Okay. Now I'm going to slide my wind velocity mark to my true airspeed line of 140. Okay, so I'm going to, whoops. So I have to scroll this up. So there's my wind velocity mark on the 140 line. And remember, we're going to read the ground speed underneath the center. So here I've got 170, 171, 172, 173, 174. I'm just going to go ahead and round down to say 173 for my ground speed. Okay. Now let's figure out what the wind correction angle is. So the wind correction angle is, you got this line that's 5 degrees, this line that's 10 degrees, so 5, 6, 7, 8 degrees to the left. So I'm going to say 8 degrees to the left. And then remember, we add right, subtract left. And so with the true course of 180, I'll subtract 8 degrees to give me a true heading of 172. Now, if you don't remember, if you're having a hard time imagining that in your mind, there's 180, 8 degrees to the left, 172. So let's go ahead and check the answers. 8 degrees left, 172, and a ground speed of 173. 8 degrees to the left, 172 for my, or 172 for my true heading, and 173 knots for my ground speed. So it looks like I got lucky on answering those correct. All right, well, I hope you enjoyed this. Keep working through the problems. I know you just started learning this, or it's been a while since you've worked on the E6-B, but once you've gone through all these problems, you'll be the master of the E6-B. Now, we didn't cover nearly everything that the E6-B can do. It truly is an amazing tool. But we cover what you need to know for most of your flight training. So, all right, well, thanks for watching.